Hello. Today is the first of a series of videos on vectors, and in today's video we're going to explore the component form of vectors and the magnitude and direction form of vectors and what each of those mean and how to convert from one to the other. Let's go. So let's start by talking about what a unit vector is. So a unit vector is a vector that is a single unit long. So if we say that that vector is 1 unit long, then it is a unit vector. And generally, we talk about the unit vectors in the horizontal and the vertical direction. So this vector right here, if it is 1 unit long in the x direction, then that is a unit vector. And in the x direction, we call that vector I. And if we have a vector that is 1 unit long going directly in the y direction, so something like that, we call that vector j. And knowing that I represents 1 unit in the x direction and j represents 1 unit in the y direction, then that means that we can start describing vectors as a combination of i's and j's. So for example, let's say we have this vector, and we know that it terminates at the point 3, 4. Well, that 3 means that it moved 3 units in the x direction. And since each unit in the x direction is an I, this x component vector would be 3i. And then if we know that it terminated at 4, that means it moved 4 units in the y direction. So that would be 4j's. And since we know that vectors add tip to tail, if we take our 3i and then tip to tail it with our 4j and then connect that up, then we could describe this vector as 3i plus 4j. And that would be the component form of this vector. And then there's a shorthand, which lets us do this, which basically just takes our point and puts it in these brackets instead to indicate that this is not a point, but rather is a vector with 3i x components and 4j y components. So these are interchangeable, and these are both called the component form of a vector. Now, there's a second way to describe a vector, because the definition of a vector is a distance or a magnitude and a direction, or a theta, an angle. So we go ahead and use our Pythagorean algebra principles to also describe a vector in terms of its magnitude and its direction. Let's start with its magnitude. So first of all, if this is vector v, we would describe the magnitude of it like this. Now, so far you have learned those two lines to mean absolute value. That is not what it means in this case. Although interestingly, magnitude is always positive, but then your direction tells you whether you're moving in this direction or that direction or whatever. But when you see the letter V inside absolute value signs, that means the magnitude of, the distance of. And hey, that right there is how we're going to find it, distance. We're going to do the distance formula. So in this case, if this is 3 and this is 4, then we find the magnitude by going the square root of 3 squared plus 4 squared. Well, let's say we would like a formula for that. Let's call them A and B instead. In that case, the magnitude, which is written like this, would be the square root of a squared plus b squared, the square root of the x component plus the y component. Okay, now, if we want to find the direction, if we want to find this theta, well, we'll use our trigonometry. If we know a and b, well, then we know that theta, opposite, adjacent, that would call for tangent. So tangent of theta would be opposite over adjacent, b over a, which means if we want to solve for theta, we would take the inverse tan. Now, there's a little trick to remember here. Inverse tan is only given from -90 to 90. So if your vector is in the first or the fourth quadrants, you're good. That's what this is going to output. However, if your vector is in the second or the third quadrants, you're not going to get the right answer. You're going to get the answer in the first or the fourth quadrant. And so the way to convert is to take this answer and add 180 degrees. Okay? So in other words, if your vector were over there, the answer that will come out of this will actually be the fourth quadrant answer. Okay? So the way to get the correct answer is to add 180 to it, right? It completes the line. This will be negative, and if you add 180, that's kind of like saying 180 minus this, which will leave you with what you're looking for. And the same thing is true if it's in your third quadrant. Okay, so let's do this with some numbers to help this make a little more sense. So let's go back to our original problem where we were given that this is a component vector of 3, 4, and they would like to know the magnitude and the direction. So to find our magnitude, that is the square root of 3 squared plus 4 squared, the square root of 25, or 5. So this vector has a magnitude of 5. And then we would take a look, since it's over +3 and up +4, it is in the first quadrant, we're good. We only make this adjustment if it's in the second or the third quadrants, right? A picture will tell you which quadrant it's in. So now we go ahead and we do tan inverse of 4/3, tan inverse of 4/3, and I've already checked to make sure I'm in degrees, and I find that that is 53.13. And I have gone from component form to magnitude and direction. Let's do it again and show you how it works if it is in the second or the third quadrant. Find the magnitude and direction of -2, 5, and you see it's in those funny alligator claws. And so that means that, again, is the component form of a vector. So I'm going to start with a picture. Over -2, up 5. That's my vector. Okay, so I'm going to start by finding my magnitude. Square root of -2 squared plus 5 squared, square root of 29. And now I'm going to find my direction. And right away, because I see it's in the second quadrant, I'm not going to mess around. As I'm writing my formula, I'm going to include that plus 180. And I find that my answer is 111.80. And if I take a look at my picture, that maps, right? This is 90, this is 180. That seems about right. Okay, so that's going in the direction of you have the component form, find the magnitude and direction. Now let's take a look at how we do the opposite. Okay, so now let's say we're facing the problem. Find the component form of a vector with a magnitude of 5√13 and a direction of 215 degrees. All right, so again, starting with a picture is never a bad idea. 215 degrees, that's going to be between 180 and 270. And magnitude of 5√13 means that's right there. If I have a vector of direction theta, magnitude v, and then my x direction is a and my y direction is b, well, let's say I want to find the b. I know that in terms of theta, this is opposite. Opposite over hypotenuse gets me the sine of my theta, right? And I know that adjacent over hypotenuse is my cosine of theta. So if I want to solve for just b or just a, I would multiply that magnitude over to the other side. And that right there is how I find my two components. So here I've got my magnitude, I've got my theta, that will get me my b. Magnitude, theta, that will get me my a. So let's go ahead and do that math. 5 root 13 times sine of 215 tells me that my y component is negative 10. 5 root 13 cosine 215 tells me my x component is negative 14.76. That right there is my component form. And as you can see, that makes sense. Over negative, down negative. And I just eyeballed this picture, but these are the real dimensions. And I don't know why I did these backwards, but this is your y, this is your x, this is your y, this is your x. But in component form, it's obviously x comma y. And if we wanted to put this in the ij version of component form, negative 14.76i minus 10.31j. And that is going from magnitude direction form into component form. You simply use these two formulas, where that one's your x, cosine goes with x. That one's your y, sine goes with y. Okay, take a look at these guys, play around with going from component form to magnitude direction and from magnitude direction to component form. Leave any questions you have in the comments and keep checking in with my channel. I'm going to do a whole series of vectors. We're going to take a look at navigation, where you're talking about traveling on a compass and how do you do that. So keep checking back in. I'm going to keep churning out new content. And as always, keep on mathing.